Let me explain. I do play VR chat, obviously. I mean, if you've seen my trigonometry video, which was a very bad review, I came across these group of cybersecurity nerds. we were just chilling, hanging out, and I was told that they were planning to do like a casual. They do this friendly casual math tournament for like the whole group of friends. Again, the majority of them are like they're all computer science people. And so when they told me about when I was invited to this math contest, and I was just like, oh shit, okay. And I was so confident. I was like, I mean, this is VR chat. Like, I feel like I'm the only person that knows math contest stuff. So I was like, this stuff's gonna be too easy. We're just gonna have like a math contest, like just for fun with all of us nerds. Like, it's gonna be very easy for me. And I was so overconfident. And then the day of the tournament, these are the problems. And oh my god, I was so wrong that I thought this was gonna be easy. This is not easy at all. I out of all these problems, I was only able to solve like around 3 to 5. 3 to 5. The first one was definitely this is the only memorable one that I could be able to solve. The rest was so terrible. They're not in difficulty order, unfortunately. But yeah, these are the majority. I don't know if it's all, but the majority of the problems that he allowed me to archive. I just put it on overleaf latex and just, yeah. I literally thought this contest was gonna be easy. I was so wrong. Like, I thought it was like, oh, it's gonna be like AMC level. This shit is freaking. This is like more than Amy. Like, oh my god. The majority of these are like Amy level, and some are like, I wouldn't say USAMO or junior USAMO, but like junior Olympiad level ish. Because there are some proof problems. Functional equations. Yeah, there are some proof problems, but they're like junior Olympiad, which I still suck at because I'm not a math Olympiad. I have no Olympiad experience. I don't have any math contest experience in general, besides integration B. Pretty much, I'm gonna be attempting each and one of these. I might regret this, but let me first show you the first problem actually, because the first problem was actually satisfying. So pretty much, the way I solve this is you're gonna let x equal this whole thing. Okay. Oh no, that was the first attempt I did, and I regretted it. The best thing to do was to do x equals square root of 2019. So now with this, we pretty much have x minus square root of x squared plus 25 minus 10x. And as you can see, this is just x minus 5 squared, and you just take out the square root. So this whole thing here is equal to 5. Did I ever tell you how much I hate word problems? So there's 23 users sitting in the first row of cinema. The player is either male or female. If each user has at least one female next to them, what's the maximum amount of males in the row? I think we do start with female first. And then female, male, male, then female, male, male. And then I think we continue this. And then the reason why we have to use this pattern is because it gives the most maximum amount of males. And each male does have at least one female next to them. So if we keep on doing this, how many is this? I'm very bad at visualization. Ah, okay. So notice that it doesn't matter how you start off, either female or male. Because if you start with male, you're pretty much just gonna get the same thing of this, but backwards. So, okay. So in that case, then this is the maximum. This must be the maximum. 1, 2, 4, 6, 8, 10, 12, 14, 15. So I guess the maximum amount of males we can have is 15. Unfortunately, I do not have the solutions. I'll most likely get wrong answers in this video, because that's just me. But if you do know the answer, please let me know in the comments, because I'm curious if I'm correct or not. A silly VR chat user is wearing a sock and a shoe on each of their forelimbs. How many different orders can the user put on its socks and shoes if the sock must be put on before the shoes? So you have 4 socks for your 4 limbs. You can wear it 4 factorial ways. That's how it works, right? Right? For each limb. So like the first limb has 4 options, first limb has 4 options, second limb has 3 options. The third limb has 2 options. Yeah, it should be 4 factorial. And then the same goes with the shoes. So it would be 24 square. 24 square, that's like 576. So I believe the answer is 576. 576 different orders that you could put on your socks and shoes. I think it's 576. An isosceles right triangle is inscribed. Honestly, I don't know any geometry terms. Things like orthocenter or like the 9 points, whatever. I don't know what any of those things are. So, separating the circle into 4 regions. Compute the sum of the areas of the 2 smallest regions. Like that. So we have an isosceles triangle like that. Oh, a right triangle. Oh, shoot. Yeah, this is the only way you can have an isosceles right triangle in a circle. Inscribed in a circle. So this is the diameter then. It has to be the diameter, because this follows Ptolemy's theorem. Is it Ptolemy's or is it Heron's? I don't know. Somewhere. Whatever. Or no, I think it's Thales. Is it Thales' theorem? I don't remember the name. All I know is that when you connect 2 lines at a certain point within the diameter, the angle is always 90 degrees. Okay. So in that case, we want to compute the sum of it. Wait. Hold on a second. Sum of the areas of the 2 smallest... hold on. You want me to compute this? And this? Oh, I'm stupid. Okay. Ignore this. And you have a semicircle, and you just subtract it with the right triangle. Okay. So in that case, is that the answer? I believe so. The sequence 2, 3, 5, 6, 7, 8, 10 contains all positive integers that are not perfect squares. Wait, what? Find the 22nd term of the sequence. Positive integers that are not perfect squares. Oh, I'm so dumb. Okay, I have an idea. No, you do count the perfect squares. You count the perfect squares. Count the perfect squares. I thought I was actually going to count them, and I'm like, wait, why not just? I completely forgot complementary counting exists. So that but then you would have to count all the squares. Well, that's nasty. Because then you actually do have to count the... Oh my god. That's disgusting. What am I doing? That's not a square. 5 square times 9 square? But, like, I don't want to calculate that. Like, come on. Like, I don't want to... Who wants to calculate this? So this would be 20... 25? Wow! Well, that's convenient. Okay. Well, in that case, so that means that we have... Also, then it is easy to count the squares then. Okay. In that case, then we have 45 perfect squares. Then there are... Don't judge me. Perfect squares, 1980. Not. Okay. So then... But then we want to we did overcount. Oh wait, no, we didn't. No, we didn't. We need to find the 2022nd perfect square. No. 2022nd term of the sequence that's not a perfect square. So you're telling me we only reached 1980? How many terms do we need to go? How many more terms do we need to go? 42 terms? 42 terms. Is there another perfect square? What's 46 square? So that means that the next upcoming 42 terms will never be a perfect square. Okay, so then we just count 2024, 2022nd term of the sequence should be 2067. I believe that is my answer. I will cry if I overcounted. Oh god, I hate combinatorics. Suppose p is a prime number larger than 21. So 23. So that if we divide, oh, never mind. Oh no. No. Oh no, it's one of these problems. If we divide 2019 by p, we will have a remainder of 21. What is the sum of the digits of p? Okay. Is this allowed? So, then we have to look at the factors of 1998 then. That's what... Okay. So maybe that's what we have to do. Is 111 prime? I really hope so. I really hope so. I'm gonna say p is equal to 111. Oh, I'm so stupid! It's divisible by 3. That's right. It's 111. 1 plus 1 plus 1 is 3. Of course. Why didn't I check that? God dang it. 111 is not prime. For obvious reasons. 1 plus 1 plus 1 is 3, so it's divisible by 3. That's our prime p. Okay. I know for sure 37 is a prime number. 3 mutually tangent circles. Okay, so this one I have solved before. This one is also another one of the problems that I solved. You have like 3 circles tangent to it. And it gives you a radius inside. The inside of the radius? Yeah, so the smaller circle has a radius of 1. What's the radius of the larger circle? What you're gonna do is you're gonna make a triangle. You're gonna make a triangle. And then after this triangle, you're going to make a... Let's see, this is the center of the... These are centers. And then you're gonna go like this. And you're gonna go like this. And this. And then you're gonna connect these two. You can connect these. We also want to find here. Right. How did I do this? Now I think about it. How on earth did I find this line here? We want to find the measure of this. Oh, okay, no, I remember now. Okay. So yeah, so that means this line here is 2 root 3. So then the larger radius here is 2 root 3 plus 1 here for this part here. So our answer, the radius of the larger circle is 1 plus 2 over root 3. That's how I solved this problem. 2 bored femboys grabbed 9 glass cups and arranged them in a 3x3 grid. They have a bottle of water to randomly splash some cups. So for each cup, it could be either filled with water or empty. What is the What? What is the probability of having no 2x... Oh, okay, hold on. Wait a second. I actually need to draw this out. What is the probability of splashing... Hold on. So just to randomly splash some water onto the cups. What is the probability that a 2x2 grid of cups? What is the probability of having no 2x2 square? No 2x2 square of water-filled cups. Well, let's first think about the total outcome. How many possibilities can we fill these cups? No, how many ways can we have these cups filled or not filled? That's like a whatchamacall those? A power set? Is that what it's? Is it a power set? I don't know if it's called a power set, but I think that's what it is. It's like, okay, this glass is either empty or full, empty or full, empty or full, empty. I think that's what it is. So there's 2 to the power of 9 possibilities then. So having 2 by 2 squared cups that are empty, I get 4 ways, right? Because I mean, there's only 1, 2, 3, 4. So it's just, oh no. No, because then this could be, then you have possibilities on the outside. Oh, that's nasty. So then for each 2 by 2 square that's empty, this could be anything, right? So for each square, there's 1, 2, 3, 4, 5, 2 to the power of 5. And then times 4, because there's 4 ways to have a 2 by 2 grid. 1/4? Is it really 1/4? Is it what? Let me reread this. 2 bored femboys grabbed 9 glass cups and arranged them in a 3 by 3 grid. They had a bottle of water randomly splashed in cups. For each cup, it could be either filled with water or empty. 25% chance of having no 2 by 2 square of water filled cups. Is it really 25% chance? Is it really 1/4? No, I refuse to believe this. No, I did something wrong. I don't think I did this correctly. No. I'm trying to imagine the situation right now in my head, and I highly doubt this is 25%. 25%? Is it really 25%? Is it really 1/4? You guys let me know in the comments. I don't know. This is the problem I actually got. I literally decomposed. I performed partial fraction with this, and it was a pain. And then one of the guys told me, you're looking for a plus b plus c plus d plus e. And you know what he told me? Let x equal -1. And I'm like, why would you do that? And I immediately looked at this. If you let x equal -1, you just get a plus b plus c plus d plus e here. So what that means is all you have to do is let x equal -1 and you just compute this polynomial. And I was so pissed that I wasted 10 minutes of my time performing partial fractions. And that all I could have done was let x equal -1. I was so... Oh no. Wait. Such that for every x greater than 0... Was he wrong too? I don't want I genuinely don't want to do this. Honestly, I'm so petrified with this problem. It's as equivalent as me trying to solve a system of equation problem from AME test. Like, no. Suppose n is a 3-digit number, so that when we subtract from n, n is a 3-digit number, so that when we subtract from n, the number whose digits this is why I hate word problems, because the wording is so obnoxious. I hope I'm reading this right, because that wording gave me a stroke. So pretty much what we have here is we have 100 of a minus c. Thankfully, this cancels out. And then we have c minus a. Oh! Ooh! This is minus a minus c, which is 99a minus c. Ooh! Ooh! Okay. Wait, what am I doing? Wait. What if we test out some numbers? What the hell? Wait a minute. This is... Wait. Are they... They're both divisible by 11. Okay. Whoa. Is it... Are we always gonna have a 9 in the middle? Wait, no. I refuse to believe this. 420. Oh, I can't do that. 421. 124. 9. 297. What the hell? What? This is actually kind of cool. Okay, wait. So then that means that we have some xy such that x plus y is equal to 9. Oh, and then, oh wait, sum of the digits. Oh, it makes sense now. What is the sum of the digits of D? Oh, okay, so that means that the sum of the digits of D is 18. Okay. Holy hell. You know what? I'll make a different part for this, so that it doesn't have to be such a long video.